Hi everyone and welcome to Elvatech YouTube channel. My name is Serge and in this video we will talk about two ore analysis modes in the portable ProSpector 2 X-ray analyzer. The first mining and the second mode mining oxides. Both modes measure the same sample, but they show the results in different ways, as elements or as oxides. In this video you will learn what the difference is between these two modes, why geologists, salmon plants and laboratories often prefer oxide format, and how to choose the right mode for your tasks. So let's get started. The first mode is called mining. In this mode, ProSpector 2 shows the results in the same way as in the standard alloy mode, as the content of elements in weight percent of the sample. For example, you may see ferrum 52%, silicon 6% and aluminum 1.5% and other elements. So you see how much iron, silicon, aluminum, manganese and other elements are actually in the ore. This format is convenient when you care about the metal content in the ore. For exploration and geology, you see how much ferrum, cuprum, nickelum, for example, and zinc the sample contains, and also for ore quality control by the content of the valuable component. Comparison with technical specifications where limits are written for elements, not oxides. You immediately see how many percent of each metal the ore contains. This is a simple and intuitive form for many tasks. And the second mode is mining with oxides. Here ProSpector 2 does the same measurement, but converts the elements into oxides according to their chemical formulas. On the screen of the analyzer, you no longer see ferrum and aluminum, but you see silicon O2, aluminum O2, ferrum 2O3 and other oxides, and also loss of ignition. Loss of ignition shows how much mass the sample loses during high temperature heating. This can be evaporation of moisture, burning of organic matter, release of CO2 from carbonates, and so on. In many standards, the ores and cement raw materials, this parameter is mandatory. Most geological cement and ceramics laboratories work with oxides composition because first, technical specifications and international standards usually define composition as silicon O2, aluminum 2O3, ferrum 2O3 and etc. Raw mix calculations for clinker, glass or ceramics are done in oxide form. Results are often compared with an external laboratory where composition is also expressed in oxides. ProSpector 2 allows you to get this oxide format without any manual calculations. The analyzer does everything for you and shows the ready oxide balance on the screen. It is important to understand that the analysis itself is the same, only the way we display the result changes. So, in short, the mining mode shows elements like ferrum, silicon, aluminum and so on. This is convenient when you are interested in the metal content and good for quick evaluation of the useful component in ore. And the mining oxides mode shows oxides like silicon O2 and so on. It is convenient when you work with standards and specifications that use oxide format. It is suitable for cement, glass, ceramics, geology and laboratory batch calculations. Often users work like this. First they look at elements, just to quickly understand their chemical composition. Then they switch to mining oxides mode to compare with standards or lab reports where everything is written in oxides. To avoid confusion between these two modes, use a simple rule. If your document reports or requirements are written in elements, use mining mode. If your specifications, standards or lab protocols are written in oxide format, use mining and oxides mode. In both cases, you get a fast, non-destructive analysis right on the site, without waiting for laboratory results. So, now you know the difference between the mining and mining oxides modes in ProSpector 2 and when it makes sense to use each of them. Use mining when it is important to see the content of elements, and use mining oxides mode when you need oxide composition according to standards and laboratory reports. This helps you to quickly assess ore quality, choose the right raw materials, and match your results with laboratory data and regulations. Subscribe to our Elvatech YouTube channel and give this video a like. And write in the comment which analysis mode you would like to see explained next.